Welcome back. This is Dan from SolveBOTICS. Thank you for joining me. In the Mobile Command Center overview video, I mentioned how the micro SD card is easily accessible and how that enables you to use different operating systems on the Command Center by simply swapping out the micro SD card. In this video, I'd like to explore this idea further and actually go through the steps to install a different operating system to see how well this process works. So currently, the Mobile Command Center is running a 64-bit Raspberry Pi operating system, but Ubuntu is also available. So that is the operating system that I will install in this video. My plan is to power on the Mobile Command Center running the 64-bit Raspberry Pi operating system, then quickly test each component like the Ethernet port, USB ports, the display, sound, and additional hardware such as this custom-made status display. This will serve to establish the normal operating baseline when running the 64-bit Raspberry Pi operating system. Then, after installing Ubuntu, I'll go back and test each component to determine if everything still works or if additional steps are needed to make everything work. If you haven't seen the overview video, the Mobile Command Center is a system I designed and built to work with the Raspberry Pi 4 and the Raspberry Pi 5. I designed the system to be portable, rugged, and to offer maximum flexibility to make working on robotics projects or other projects much easier. Because when you're working on those projects, there are many problems you have to figure out and to solve, but figuring out how to move your monitor and your keyboard and mouse and how to power it all should not be one of them. So before I move on, I'd like to say thank you. Thank you to everyone who has subscribed and liked my previous video. I really do appreciate the support. And if you're new to this channel, again, my name is Dan, and I'm the founder of SolveBOTICS. And this is a place where I like to share projects I've worked on or I'm currently developing. And the ethos behind SolveBOTICS is to learn, apply, and solve. And to me, these are not just words, but rather a plan of action that has helped me to solve difficult and challenging problems in the past. So I'm looking forward to learning new things and applying that new knowledge to solve new problems together. So with that in mind, let's go tackle today's topic. Okay, I'm back and I'm ready to run through the components and do a baseline test of everything. Before I do that, I want to first establish that the version of the 64-bit Raspberry Pi operating system I'm running is the Bookworm release, and the actual Raspberry Pi I have in there is a Raspberry Pi 4 Model B revision 1.5. Okay, ready to start. So you can see I have the Ethernet cable plugged in, and if I run the ifconfig command, I get an address of 192.168.0.240, and that matches what is on the custom status display to the right. And so in just that short amount of time, I've tested Ethernet cable, USB, touchscreen capability, and then the customized hardware. Let's move on to sound. So for that, I'll knock out the other USB test and plug in my USB drive, and that should bring up a prompt. So I'll use the touchscreen capability. I'm using a keyboard. So this just demonstrates that everything is working with the current operating system. Okay, we have sound, and I'm able to use the keyboard controls to make it louder or quieter or mute it altogether. Okay, so all that is a quick test of all the hardware components that they're working with the 64-bit Raspberry Pi operating system. I used the Raspberry Pi imager tool to flash the Ubuntu operating system onto a micro SD card. There are different versions available, but I selected Ubuntu Desktop 24.04 LTS, which stands for long-term support, as the operating system to use for this video. I'm ready to install the Ubuntu 24.04 LTS operating system. So I'm going to go ahead and remove the card that has the 64-bit Raspberry Pi operating system. Place it to the side. And here is Ubuntu. I filmed the entire installation process, but I've shortened it to only show the key moments in this video. The first thing you'll see is the splash screen, followed by a view of the desktop. Then you'll arrive at the system configuration menu. The installation process is straightforward, with many of the prompts asking the user for customization settings. These, of course, will be different for each user. I selected the username of MC2 or MC squared, and by default, Ubuntu requires a password to log in, and that's how I left it. These two settings are important because they make an impact later on in this video. After those settings are entered, the installer will display a welcome screen while continuing to run installation tasks in the background. The installation process takes at least 30 minutes to complete. Okay, so I'm back and the installation is complete and I'm ready to log in. So let me go ahead and do that. And at this point, the touch screen is working. And I am going to skip that option for now. I do not want to share system data. And finish. Okay, let's start checking out the components. Keyboard. I hit Control Alt T, and that brings up a terminal. Okay, I'm able to run commands. Okay, that's good. Let me run an ifconfig command. Not installed. Okay, that's because I need to install NetTools. Okay, so the IP address here is 192.168.0.240. Okay, Ethernet's working. Good. And that's not a surprise. It was working during the install and was able to apply updates. Okay. Let's get out of there. Let's check out the USB ports. Okay. I'm able to move the mouse cursor. USB 1, USB 2, the same. Let's check out sound. The same way we did before. So the touchscreen is working completely now. There's no issue there. This is a nice touch where it tells you where your volume is. I didn't have that in the other operating system. Those controls work. I can mute, I can change the volume. Okay, and we can hear sound. So that's working just fine. At this point, I've tested the Ethernet and the USB ports, as well as the sound and the touchscreen display, and all of those components work. The last component to test is the custom status display. This display will not run by itself. It requires additional software libraries and a Python script to drive it. To get this display to work on the Pi 4 or Pi 5 when running the Raspberry Pi operating system, I followed a tutorial written by Klements. It's an excellent tutorial because every step listed in it just works. However, the question is, will it work on this Pi running Ubuntu 24.04 LTS? And the short answer to that question is yes, it will. The slightly longer answer to that question is yes, it will. However, it requires a few key changes. So I'm going to switch to a different setup where I can do a screencast, and I'm going to go through that tutorial step by step, and I'll issue each of the commands, and then I'll show what I did differently to get it to work on this system running Ubuntu. So as I mentioned earlier, I relied on a tutorial written by Klements to add an OLED status display to the Mobile Command Center. And when used on the bookworm version of the Raspberry Pi operating system running on the Pi 4 or the Pi 5, this tutorial works without having to make any changes to it. However, to adapt it to run on Ubuntu Desktop 24.04 LTS, I needed to make 5 major changes to it. The link for this tutorial is in the description of this video, but to make it easier on myself, I copied all of the commands in it and pasted them into a text file. This allowed me to run them one after another and add notes as I made changes. The first command to run is the update command. This is followed by the upgrade command. Both of these will update and upgrade the Ubuntu system packages to the newest versions. After running these commands, it's time to reboot. This next command installs the package manager for Python 3. An upgrade of Python 3 setup tools is run as well. This next command is the first change I made to the tutorial. You will need to run I2C tools to detect the OLED display in a later step, so it made sense to install it at this point. These next 3 commands will create and activate a virtual environment for Python 3. This is needed to install some of the libraries to drive the OLED display. This command activates the virtual environment. With the virtual environment active, these next 3 commands can be run. This will install the Adafruit-Blinka library, which will enable CircuitPython to run on the Raspberry Pi. This step is where I made the second deviation from the tutorial. When trying to run this command on Ubuntu, you will receive an error message that it can only run on the Raspberry Pi operating system. So I omitted this command and everything turned out fine. The next step is to deactivate the virtual environment and issue a reboot command. After the reboot, it's time to run the I2C tools to determine if the OLED display is connected properly and ready for communication. An address table will be displayed, and if the value of 3C is present, then everything is working correctly. After verifying I2C communication, it's time to activate the virtual environment again and install the CircuitPython libraries for the OLED display. After installing the CircuitPython libraries, it's time to exit the virtual environment and install Git, which will allow us to download Michael Klements' Python scripts for driving the OLED display. After the scripts are downloaded, it's time to re-enter the virtual environment to run the scripts. I change the directory to OLED_stats. I then proceed to run the Python script named stats.py. This produces an error because the gpiozero module is missing. Fortunately, it's easy to install this module, but this is where I make a third deviation from the tutorial. I start by deactivating the virtual environment, then I run the command sudo apt install python 3-gpiozero. With the gpiozero module installed, it's time to retry the Python script. To do that, I need to re-enter the virtual environment, then change the directory back to the OLED_stats directory. Now I'm able to run the stats Python script and there are no errors. But to see if it's really working, I need to take a look at the actual OLED display. I'll now jump out of screencast mode and rerun the Python script to show the OLED display in real time. So now I'm in front of the Mobile Command Center and I'm ready to run the stats Python script in real time. Because I haven't run it yet, the OLED display is currently blank. I repeat the steps to activate the virtual environment, then change directory to the OLED stats directory. Then I run the stats Python script. And the script works to drive the OLED status display, but there is something wrong. Near the CPU temperature, I get an error message that something cannot be opened, and there are garbled characters where the memory utilization is displayed. To figure this problem out, I opened Michael Klements' script and located the commands that retrieve the system data, such as CPU temperature and disk usage. I then ran each command individually in a terminal window and discovered that it was the vcgen command that was generating the error. When this command is run, you receive an error message that the device file /dev/vcio cannot be opened. As a result, this error is returned and displayed on the OLED display. This can be fixed by adding the user MC² to the video group, and this is the fourth change or deviation I made from the tutorial. This is done by issuing the command sudo usermod -a-g video mc2. This change will not take effect until after a reboot. With the user MC² added to the video group, the vcgen command now returns the CPU temperature without any errors. So now it's time to rerun the stats Python script in real time to see if the OLED display will work correctly. Okay, so I'm back with this setup because this is the only way to really show this. But I've added the user to the video group. So now I am able to run the measure temperature command, and instead of it displaying an error saying it cannot open file, it will actually report the CPU temperature. But at this point, I have not rerun the script, and you can see that the display still has this error. I'm going to go ahead and go back into the virtual environment, rerun the script, and that, with the user added to the video group, should correct this. So, stand by. Okay, I'm in the virtual environment. I'm going to cd to the OLED stats directory. And now I'm going to rerun the stats Python script. And there, now everything is working perfectly. I now return to the screencast mode, and the next step is to install curl. Curl is used to download Michael Klements' OLED display script. After it downloads, it needs to be made executable. That's because it will be used to activate the virtual environment, then run the stats Python script upon startup. This brings me to the fifth and final change I made to the tutorial. In the tutorial, Michael Klements uses cron tab to set up a cron job to execute the OLED display script upon a reboot. This works for the Raspberry Pi operating system because it's not configured to require a password for the user to log in. However, I currently have Ubuntu configured to require a password, so the OLED display script cannot run since the user MC² is not logged in after a reboot. So the change I made was to not set up a cron job at all, but to add a launcher for the OLED display script to the .config autostart directory. This makes it so that the OLED display script will be run not at reboot, but when the user actually logs into Ubuntu. So I started by changing the directory to .config/autostart, then used the text editor to create a file named OLED_display.desktop. I then pasted the line seen on the screen into this file and saved it. If you want more detail on how to start an application automatically upon login, I've copied the Ask Ubuntu resource that I used into the description for this video. With this last change, it was finally time to test everything out. A recap of the 5 changes I made are also in the description for this video. So I'm going to go ahead and do a reboot here, and we'll see if this works. Okay, not logged in yet. Let me go ahead and do that. And there we go. So now the status display script has kicked off upon a login to Ubuntu. Let me do a close-up on that. And so currently the Ethernet cable is not plugged in, but the temperature for the CPU is updated. And let me see if the IP address will show up after I plug in the Ethernet cable. And there we go. So I have the Ethernet address of 192.168.0.240. IP address working. IP address working on the custom status display. So that is Ubuntu 24.04 LTS running on the Mobile Command Center. And everything is now working. So I would call this a successful install of that operating system, and this just further illustrates the flexibility of this system. So the conclusion is that Ubuntu 24.04 was successfully installed on the Mobile Command Center. All major components worked, including the custom OLED status display. It feels great to accomplish something I set out to do. I hope you found value in today's video, and if you did, or you'd like to see other topics presented, let me know in the comments. This is Dan from SolveBOTICS signing off. I hope you have a wonderful day.